Hi, today I will show you how to create a nice simulation of the gravitation between points inside Blender. I'm using Blender 4.1, which is a release candidate, but it works also on Blender 4.0, so no problem, okay? We will use the default cube because it's okay to use it. You can create a sphere, whatever you want, but let's use this default cube. And we will use the Newton's laws, especially one formula from the Newton's laws to calculate acceleration vector of each point, okay? So let's create a new geometry node. I'm using this tab, the geometry nodes tab, because it's a nice workspace to work, and we can create here a new geometry nodes like this. And before making our geometry nodes works, I want to explain just a bit what we will do with the Newton's formula. Let's take a point, name it B1, because this is a body 1 with a mass 1, okay? And let's take another point, which is B2 with a mass M2, okay? So we know that B1 is attracted by B2 and B2 is attracted by B1. So there is a force going like this, okay? And the force is between the 2 points. And what we need to know to make our simulation is the strength, so the acceleration strength, and where should go B1 to give the new position of B1. And one formula from the Newton's law is the acceleration is the g constant, which is the constant of gravitation. It's a tiny value for the real universe, but we will use another one to make the simulation working faster inside Blender. And we need to multiply this by the mass of the object that is attracting our object. So for example, if I calculate for B1 to know where B1 should go, I will use the mass of B2 because B2 attracts B1, okay? So I'm using M2, which is the mass of B2, and I divide this by the square of the distance between B1 and B2, okay? This strength is actually made for a certain time. So this is what we name delta t for delta time. No problem. Blender gives this value. And we need now to know where goes B1. Because actually here I only calculate the strength, but I need to have a vector. So I need an acceleration vector. And to have a vector, we need to multiply this by a unit vector. This is very easy to understand what it is. This is the same vector, the same vector which goes to the same direction of this acceleration vector, but the size is 1. So it doesn't change the strength, it only gives a direction. This is why we are using a unit vector. Okay, but what happens if, for example, I've got a new point here, another point here, which is B3, with a mass. So at this time, B1 is also attracted by B3. So there is another force going like this. And so B1, where goes B1? It's pretty easy to know where it goes. We only need to calculate all the acceleration vector for each point, and we need to add them. So B1 should go, we can take this vector, we add it here, and we know that B1 should go here. Okay, so this is the new position. And then we will need to do this for B2 and B3. This is necessary to make moving all the points. So B3 will go somewhere here and B2 will go somewhere here. Okay, so this is a double loop. We need to do for each point, we need to get all the other points, so this is another loop, and we need to calculate all the acceleration and to compute the new position. Okay, so are we able to make all of this calculation inside Blender? We can use a value for g because this is a constant, so this is not a problem. We will be able to add and you input or a value. Okay, for the distance we will need to calculate something between b1 and b2, and I will explain this just afterwards. And for the delta time, no problem, because Blender gives us the time between two frames and the unit vector is needed. We will calculate the distance and the unit vector on the same time. But what happens with the masses and the acceleration vectors? Because I need one acceleration vectors per point and a mass per point, and Blender only gives us the position and the radius of a point, but not the acceleration vector and not a mass. So we will add these values manually with something named named attributes. So we will store a named attribute and we will read the named attributes of our point. So this is not a problem. Okay, so let's go to compute the distance and the unit vector. When you work on Blender, if you have this point here and this point here, for example, Blender gives the position as a vector from the origin. So this is a vector, okay? So the position is a vector, and to compute the vector coming from B1 going to B2, which is, for example, the V vector here, I will name it V and not U. The V vector is computed by B2 vector minus B1 vector. This is the destination minus the origin, okay? And it's cool because we have the V vector, and this allows us to get the length of the vector, because Blender has a node to compute this, and there is another node which is named normalize, which is a normalize operation, and the length is D, and the normalization of the vector is the U vector. So it's cool because we have everything to make this calculation of the formula. Okay, so we are able to make all of this, and there is now a new problem to manage. Let's go to the node, and I will explain something that a lot of beginners don't understand. It's actually not so complicated, but it could be confusing. So if I use, for example, the position node, okay, I get the position node. What you see here is that we have a slot, and this slot is a diamond shape, and not a circle like this, not a disk. This is a diamond shape, and that means that, oops, if we take the value from here, we will have a stream. It's like an array of value, and Blender will give you the position one by one for each point. So this is for each point loop. This is already a loop. You don't need to create a loop for this. So when you work on with this kind of stream, actually Blender is going to make the calculation for each of your points. So this is cool because this is easy to create our nodes, but it makes the computation a bit confusing sometimes. But what I advise you is we will take in account only these points. As an example, this is B1, and we will be able to manage everything. So we will calculate the acceleration for this point, and actually Blender will do it for all the points afterwards. But we will need to make our manual loop, because when I've got the position or the mass of a point, I will need to calculate the acceleration to the other points, and the other points we will need to get them. So we will need to create our own loop, and I will show you how to do this. But at first, what we need to do is to create our points, because at this time we only have domain, which is this cube, and I want to create points inside this cube. So there are many ways to create some points inside this cube, but I will show you what I do. I change the mesh with mesh operation to a volume. So I do mesh to volume like this. So this is now a volume. You can remove this value to 0 because the interior bandwidth is not necessary for our geometry. And let's now distribute points. So point distribute in volume like this, and yeah, it's okay. We now have our points. If you take a look on the left tab here, you have a point entry like this, and you can see that we have here 12 points with position and radius. So as I said earlier, we don't have mass and acceleration for this point, so we will need to create them. It's very easy to do. Let's press Shift A to add something, and let's use attribute store named attributes. This is exactly what we need. This node will create a variable on each of our points inside the geometry. Let's name it mass because we need a mass. Don't forget to set the value to 1. We don't want null value. We want something with a mass, so 1 is okay. And let's connect this, and as you can see now inside your tab here, you have now a new column with the mass, and we will need an acceleration vector for each point. So let's do the same, store name attribute like this, and this time this is not a floating point value, we need a vector. So let's click on vector, name it velocity because this is more explicit, and you can now connect this, and yeah, it's okay, we have velocity for each point, and this is okay. We can now work on our gravitation simulation. Okay, so the first thing to do, I will need space because there will be a lot of nodes. Because this is a simulation, we need to make this calculation for each frame. And in geometry nodes, there is a zone which is named simulation zone, and this simulation zone is executed for each frame. So each time you go one frame forward, you will calculate what is inside this purple zone. Okay, and as I said earlier, there is the delta time here, so we will be able to use it. Okay, so it's okay. Now what we need to get the mass and the distance. Let's take the distance at first because this is maybe the more complex that we will need to compute. So let's try to get the distance at first. Okay, the distance is B1. From B1 we need to get all of the other points here, and we will need to calculate the strength and the vector here and the distance from B1, I take it as an example, to B2, then B3, then B4, etc. And how to do this? To have the position of B1, it's actually easy because I can use the position node, okay? But how to get the position of this point now? Because I need to do, let's select this point and give me the position. And there are two methods. The first node is to use the sample index. Sample index is very cool because if you take a look on the left here, you have here a number, and this number is named index. This is the index of your points. So there is a point 0, a point 1, 2, 3, 4, 5, and so on. And this is what it's named, the index. So we can say, okay, sample a value from a certain index. You need to connect the geometry here, and then you can say, okay, I want something in at this point. Okay, so this is cool because we can select which index to use, but we need to get here the position. So this is a vector like this, and I can say, okay, let's get the position. And this is what some beginners don't understand. It's that actually what Blender does here is to give all the position of the all points inside your domain, and we only output one value from this index. Okay, so as you can see here, we are sending a stream, and this is the position. So this is the first node that we can use, but there is another one which is maybe simpler to use. This is evaluate at index. Evaluate at index doesn't need to have a geometry as an input because it will get the geometry later, because Blender can send back the geometry we are connecting to the entire nodes, and this is maybe simpler to use this one as the simple index. So we can remove this, and now I can connect the position here and use the vector, and this is the position of the point 0, point 1, point 2, and so on. And this is now that we will need to create our own loop, because what I want to do now is to get I've got the position of B1, and I will need to do for each the other points, getting their position and calculate the distance and the unit vector to make all the formula at once, calculate the acceleration, add it to my point acceleration, and continue. And what I need to do is to go from 0 to 11 here, because we have 12 points, okay? And how to do this? This is not so hard to do. Let's create a utility repeat zone like this, and this is exactly what we need. We need to create a repetition. This is a loop. So what we need to do, we need to say, okay, do it 11 times, but making this manually is a bit it's a bit stupid because we can set the number of iteration automatically using the domain size here. You can have the point count here, and let's use a point cloud because this is a point cloud, okay? And now if I mouse over my iteration entry, you can see that this input has 12. So I will do it 12 times. And what do I need now? I need to change this value here for each iteration, and it's pretty easy. Let's connect a new entry to the index. So now we have a new variable for the repeat zone, and this is the index because it takes the name here, but you can change it. There is no problem for this. And what we need to do is say, okay, let's start at 0, so I can get the position of point 0, and then I need to go to the index 1. So I need to add 1 to the index, and it's pretty easy. Let's add a math add. This is a math vector. Let's add 1 and connect this to the index. And so after having made all the computation here, it will add 1 and go here, and it will do it 12 times. And this is cool because now we have our loop, and we can now create the rest of the formula. So here I've got the B2, B3, B4, and so on position. So what I will do is to make a frame around this nodes to keep in mind what I've got here. So I'm using the node wrangler add-ons, and I can say, okay, Shift P to create the frame, F2 to rename, and I will say B2 position like this. Okay, B2 like this. Okay, so this is the B2 position, and now with this I can calculate the vector from B1 to B2. So let's frame it to see what it is. This is the B1 position like this, and I can do B2 minus, so this is a subtract mass, subtract like this. Oh, this is not for a vector mass, a vector mass, excuse me. And so this is the subtraction. So I subtract the B2 vector on B1 vector, and now I've got the vector from B1 to B2. And as I said, we can use the length here, and we can use the normalize operation. This is the U vector, F2 U vector. vector. Okay, and this is the length, this is the d value, but what I want to do is to frame d square because this is better to keep to have the same name as inside the formula. So I will just make the power of 2 here. This is exactly as square the value, and now this is the d square value. Okay, and this is cool because we have now u d square, and we need to now use the mass. So what I want to do to have the mass, evaluated index is exactly what we need. We will evaluate at index a floating point value to inside this index, at this index, sorry, and let me just remove this mess sx0 like this, and I will glide on y like this. Okay, I will evaluate at index, but this is a named attribute here, named attribute, and I want the mass. Okay, so this is the b2 mass like this. Okay, so this is the mass, and now we have the mass, we have the d square value, we need to get the g value, and we need the delta time. The delta time, as I said, is here, and I will multiply this by a g constant. I prefer to use an entry, a geometry node input here, because this is easier afterwards to make some modification without to find where is my node. So I will create here, I will use the input, the group input here, and I will create a new variable here. Okay, so this is very easy now because I would just want to multiply the g value by the delta time, because I can, because this is multiplication and division, we can make all the calculation to the wanted order. Okay, so I change the order, and I will multiply this. So I say multiply this value by this value here. If you want to switch, just use Alt key and you can do this like this. Okay, so I want to change this name because this is not cool. Value is not okay. This is G. And it's a single value. This is not a string, so this is not mandatory, but I prefer to change this. Let's remove the mess. Okay, and for the g constant, I want to change the default value to 0.005, for example, and this is just to make things a bit easier to use, but it's not mandatory because we will change this inside your values here, and let's change the value to 0.005 at this time. It's probably okay. For the minimum value, I will set it to 0.00001, and for the max value, let's say 1. 1 is a huge value for the constant of gravitation, but it's not a problem. Okay, so what I did here, what I did is I did g multiplied by dt, and I need now to multiply by m2. So let's multiply this like this with the mass, and let's divide this by d square here. Let's divide like this. I prefer to make the to compute all the multiplication for the floating point values at first and later use the vector. Okay, so now I can multiply this value by the vector, and so what we can do, we can of course multiply the vector by a value. This is okay, it could work in Blender, this is not a problem, but as you can see, this is a floating point value, this is a vector here, so Blender will set the value to x, y, and z, and actually multiplying a vector by a value is exactly the same as scaling a vector. So I prefer to use scale. This is exactly the same operation, this is exactly the same result, but it's prettier. Okay, and now we need to add this acceleration to the previous one, so I need to add to the named attribute, which is the velocity. okay? And I need to keep the new computation, the new value of the gravitation on the named attribute. So let's store name attribute this geometry like this, and just connect this like this, and this is the velocity. Okay, so it's cool because now the operation is done, and we have made we have stored new acceleration vector. And as I said, this acceleration vector gives the new position, but the new position from the starting point. So we need to add this value to the current position, and this is not a problem because Blender, so let's do it after the repeat zone, but inside the simulation zone, let's set the position of my points, and as you can see, there is an entry here for the offset. So this is what will be added to the current position, and I just need to connect the name attribute, which is the velocity, and this is okay. So now if I press play, so this is the play button here, or you can press the space bar, you will see the simulation, and it should work. So it works, yeah, but what happens? What you can see, so just one thing, go back to the first frame at each time you're changing something inside your geometry nodes, because as you can see, there is a purple line, and it means that Blender bake your animation. So the animation is made in cache, and afterward it will be very cool, because sometimes when we have too much of points, it's slow to compute everything, and then when you replay the animation, it's smooth. Okay, so what I said, there is a problem here. The problem is that if I go to, yeah, let's take a look on these points here. I go frame by frame, and what you can see is that when they collide, there is like an ejection, and this is actually a very common problem in simulation, because we are not managing collision, and we will not. But there is a problem here, because when the distance here, I just take a look on, let me explain like this. If I check this, the distance when we collide here is 0, or a value near 0. So that means that here our division is made by 0. This is a division by 0, and this is not cool in math and not cool in computing. So what I need to do is to fix this, and what we do in simulation only is to add a tiny value which we name epsilon. This is a very tiny value, so we will do it, and this is very easy to do. We will go here, and after calculating the power of the distance, we can use a new node, and we will add, for example, 0.02. Okay, so let's go back to the first frame, and let's play, and this is okay now. Okay, there is another ways to do that I'm using sometimes, because I want to not continue to change the gravitation strength when two points are colliding. I can use, I add here the sum of the radius, so I can sample at index the radius of this point and add it to the current radius, and I set it to the value. But you can do it afterward if you want, but sometimes it's not very cool. So I will leave a tiny value like this, and this is okay. And what I did here is to set the G constant here. You will see that we will probably need to change it to reduce a bit, because sometimes it's too fast. Okay, so now we can make something just a bit more, a bit prettier, because we are using here is a cube, and this is not like a galaxy. So I will change this, but I want, I just keep in mind that you need to set the density to 1 before changing anything inside your shape here, because sometimes when you scale your mesh, the number of points could grow very quickly and you can crash Blender. So limit the number of points to 1000, and afterwards you can change a little bit your density, but leave it to 1 before this. Let's remove the cube in edit mode and add a new UV sphere. Yeah, scale it on Z to make it a bit flat like this. I will leave it like this, and scale, but not on Z, to have a galaxy. And I take a look on the left to see that I have not too much of points. Okay, so let's make it like this. This is cool. Now you can leave the edit mode and change the density to, for example, 3. We have, yeah, it's okay. I can give it more points. I will grow to 500. Yeah, okay. And you can now press play and you can see that it works very well. It works very well. Okay, and there is some orbits and it's okay, but because we have now a lot of masses, it's maybe a bit fast. So let's reduce the G, the constant here, to 0.008 like this maybe. Blender will run the values visually, but if you click on, you can see that this is the good value. Maybe it's, yeah, it's okay, it's cool. Okay, so this is the G constant, and I know I have a new better animation. But what we can do now, all the points are sized to 1 and they all have the same mass. I want to make it a bit more chaotic, so let's move this like this, and I want to change the mass to have here random value. So as you can see, this is a stream, so I will create random values and there will be 1 random values per point. Okay, so let's go to random value like this and set the minimum to 1, the maximum to 8, for example. And now if you take a look here, you can see that the masses are all random. So this is cool. This is what I want. And what I need to do also is to change the size. I want to change the radius, but I cannot change the radius somewhere. I don't know where they are. I think the default size is 0.05. I know it because I would change it. So you cannot change this here, but you can add set point radius like this, and as you can see, this is 0.05. But now if I connect this random value to the radius, because I want to see which one is massive and which one is not by the size. So if I change the radius and I set it to from 1 to 8, but the radius is 0.05, all the points will be very huge. So let's take a look. It's not possible like this. So I will just divide the value of the random value to change the radius, but not the mass. So I divide, this is a math node. It's odd to say math and mass for a Frenchman like me. Let's divide by maybe 60, and yeah, it's better like this. Okay, so now what I want to do is to have the minimum and maximum mass and the scaling of the points as an input. So let's connect the minimum here, the maximum here, and the value here, and we will change this. This is the min mass, this is the max mass, and this is the point radius scale. Okay, so this is a bit more easy to control like that. So let's glide it like this. Okay, so now we have different masses and different radius. Only the masses are used to compute the Newton's formula, and that works. Maybe the G constant is way too high. One more time. Let's give it like this. This is better. I set it to 0.0003, and this is okay. As you can see, sometimes the frame rate is a bit slow, but after having baked the animation, everything is cool. Okay, so that's very nice. Okay, so now what we can do, we can points are okay to see what happens, but we want to have stars, planets, whatever you want, and maybe we can change this to make instance on point now. So this is now very common. What you will do is to, after the simulation, we can add instance on points like this, and we can, for example, use a icosphere. As you can see, one more time, the radius here is a disk, so we cannot set a stream of radius, but we can use the radius on scale here. So I will connect this to the radius of my points, and this is okay. So each icosphere is sized by the radius of the corresponding point, and I will change the number of subdivision because I prefer like this. I will set shade smooth, and maybe I will assign a material like this. So let's use the default material. Let's change the material now. I will use a greenish value like this and go to the preview, and yeah, it's cool, it's very nice. And if I press play, it works great. It's okay. So of course you can, if you want to, here I'm creating icosphere, but you can drop any object here and let's and connect this as an instance, so you can create planets, asteroids, whatever you want, and use it instead of using an icosphere. You can use your own objects. It's not a problem. This is just here an example, but it's very nice. It's very cool, that work. But anyway, you can, for example, make more points. So now it's a bit complex because I made instance on point. This is problematic to have the number of points. So let's use a viewer like this to have the number of points here. Let's do maybe, I don't know, 25, maybe 29, and I've got here 700. Oh, let's go. Okay, so go back to the first frame. Let's remove the viewer, and now it works, and you can see that this is slow. Now the frame rate is slow. I need to leave the baking to finish, and it will be smooth afterward. And that works. Okay, so this is cool now. And I can remove the overlay like this, and yeah. Okay, so there is another thing that I want to do. This is changing a bit the initial velocity, because at this time, as you can see, if I go back to the first frame, all the points are statics and they all collide on the centers, but I want them to move around just a little bit. The origin. So what I will do is pretty easy to understand. I will use the fact that a position is a vector. So because this is a vector, we can use them to, we will reduce them as a unit vector by the normalization operation, and we will make rotating 90 degrees around z. So any the all points will have a vector like this, and this is cool because this is an initial velocity, and then we will leave the acceleration to make the compensation of the rotation. So this is very easy to do. Let's go on at the beginning here, and this is the velocity. So you can see that this is 0 velocity. We will make this we will change this vector to have an initial rotation. So this is cool. Let's go to position. Oops, this is not points, this is position. And as I said, I normalize the vector. Let me zoom a little bit. Then we can rotate the vector, and we will use the z-axis to set it to 90 degrees, and we will scale the vector a little bit because we will need to change the strength of the rotation. So I will scale like this, scale, and let's say 0.03, for example. This is a random value at this time. I don't know what is the result. I will change it just afterwards, and I now can connect to the initial velocity. And if I go back to the first frame and press play, as you can see, there is an initial velocity which is a rotation, and this is way more like galaxy. Maybe 0.03 is not enough. I will set it to 0.06, for example, and yeah, this is a bit better. Leave the animation to be baked, and we will see if it's better after having made this in cache. Yeah, so this is cool. Oh yeah, I like it. This is very cool. And one more time, you can connect this to the input if you don't want make too much of links crossing together. Let's add the group input like this, and this is not the scale. This is, for example, the initial rotation strength, like that. And so inside your geometry node tab here, you can change the rotation here, the strength of the rotation here, and this is cool. Okay, so this is the end, and I hope that my video shows you some nice tricks to create some simulation. Don't forget to like, share, comment the video. Thanks for watching, and bye bye.